Welcome to our physics lesson today. My name is Purity Anzelimo, and our topic of today is quantity of heat in book 3. So in our lesson today, we continue with the quantity of heat as our topic, and we move on from where we left during our previous lesson. Now, during our previous lesson, we looked at the specific heat capacity, denoted by a small letter C. And we said that specific heat capacity simply refers to the amount of heat required to raise the temperature of a unit mass of a substance by 1 Kelvin. And therefore, we say that specific heat capacity is given by the quantity of heat divided by the mass of the substance multiplied by the change in temperature. So make note of this, and from this, therefore, we can say that quantity of heat, when we cross multiply, quantity of heat will therefore be equal to mass multiplied by the specific heat capacity multiplied by the change in temperature. So we are going to make use of that formula. Make note of it. So quantity of heat is mass times specific heat capacity multiplied by the change in temperature from the definition of specific heat capacity. Now, before we look at the continuation on the specific heat capacity, where we are going now to look at the determination of specific heat capacity using different methods, and in our case today, in this lesson, we look at the method of mixtures. But before that, I would like you to note the following. NB. Now, if we have two substances which have the same mass and they are being heated by the same amount of heat, now we'll have them having different change in temperature. You need to note that. For example, if we have a substance like a metal like iron, and maybe we have another substance, for example, we can talk of copper. Now, when these two, let's say they are of the same mass, let's say the mass of iron that we are heating is maybe 10 kilograms. And also the mass of copper that we are heating, let's say, is also 10 kilograms. When we subject it to the same amount of heat, they acquire different temperature changes. And this is because they have different heat capacities. So I want you to note that. So we are saying that, if two substances So I want you to note that if two substances of the same mass are subjected to the same amount of heat, let's say we are heating them using a certain amount of heat, for example, 1000 joules. We are saying that they will have different temperature changes due to their different specific heat capacities. Hopes that is clear, because these two substances have different heat capacities, and therefore, even if we subject them to the same amount of heat, they will going to experience different temperature changes. For example, if we talk of inch iron, whose specific heat capacity is 460 iron, whose specific. Now we are taking an example of iron whose specific heat capacity is 460 joules per kilogram per Kelvin. So we are saying that when we supply heat of 416 joules to a unit mass of iron, the temperature change will be 1 Kelvin. So make note of that. So iron whose specific heat capacity is 460 joules per kilogram per Kelvin means that, when we supply heat to 1 kilogram of iron, it means that it will give in or out 460 joules. That is the heat in 1 Kelvin. That is a temperature change of 1 Kelvin. So we can say that 1 kilogram of iron would give out or in 460 joules of heat when the temperature changes by 1 Kelvin. So we can say the following, that because we have 460 joules per Kelvin joules per kilogram per Kelvin, then it means that 1 kilogram of iron will therefore take in or out. So make note of that, when we are saying that the specific heat capacity is 416 joules per kilogram per Kelvin, it means that 1 kilogram of iron will take in or out 416 joules of heat when temperature changes by 1 Kelvin. And this qualifies what we are saying, that when two substances of the same mass are subjected to the same amount of heat, they are going to have different temperature changes due to their different specific heat capacities. So if we have another metal, for example copper, the specific heat capacity will be different. So meaning that in this case, for example, where we are saying 1 kilogram of iron taking in or out 416 joules. So in case maybe we have another substance or another material, then it is going to take in or out a different amount of energy depending with the specific heat capacity. So 1 kilogram of iron from this will take in or out 416 joules of heat when temperature changes by 1 Kelvin. Hoping that that is well understood, you can be turned to explain what that means.